Welcome to the DefCam. Pakistan's integration of the Chinese-origin PL-17 ultra-long-range air-to-air missile onto its J-10C Vigorous Dragon fighter fleet represents one of the most consequential developments in modern aerial warfare, redefining the balance of power across South Asia. The decision to operationalize this system marks a deliberate attempt to bypass traditional force asymmetries by leveraging technological breakthroughs that allow a numerically smaller air force to hold at risk the very assets that enable adversarial superiority. The PL-17 missile, engineered for engagements at ranges beyond 400 kilometers, when paired with a networked 4.5-generation platform, such as the J-10C, creates a new paradigm of air dominance centered not on dogfighting or short-range missile combat, but on strategic interdiction of high-value airborne targets far behind contested airspace. The physical integration of this missile was itself a complex undertaking. The J-10C airframe required significant reinforcement to accommodate the missile's extraordinary dimensions and mass. With a 7-meter length and an estimated weight of 2,500 kilograms, demanding structural hardpoints that surpass the tolerances of earlier pylons. Pakistan's engineers, in collaboration with Chinese counterparts, introduced reinforced titanium aluminum alloy centerline pylons capable of bearing the immense load while preserving aerodynamic stability. These pylons were not simple mechanical mounts, but complex electromechanical nodes, featuring advanced data buses for high-bandwidth communication and robust power delivery systems that replaced the legacy pneumatic and hydraulic release mechanisms used for smaller air-to-air weapons. The integration also required recalibration of the J-10C flight control software to compensate for altered center of gravity characteristics, ensuring maneuverability remained sufficient for operational deployment. Beyond the physical challenges lay the issue of targeting. Since the PL-17 maximum range extends far beyond the detection and tracking envelope of the J-10C indigenous KLJ-7A active electronically scan array radar. A missile capable of hitting targets at 400 kilometers cannot rely solely on onboard sensors limited to less than half that range. Pakistan's solution has been to establish a multi-layered sensor architecture designed to provide the necessary off-board targeting data. This architecture integrates Karakoram Eagle airborne early warning and control aircraft, long-range ground-based L-band radars, Chinese-supplied YLC-8E anti-stealth radar systems, and electronic intelligence streams derived from both ground and satellite assets. The data fusion process takes place within the J-10C mission computer, which has been equipped with bespoke Bayesian tracking algorithms developed to minimize positional uncertainty and refine target tracks to a margin of error below half a degree prior to missile release. The missile itself carries its own advanced guidance system, ensuring effectiveness even under contested electronic conditions. Its tri-mode seeker employs inertial navigation for the mid-course phase, Ku-band active radar homing for terminal guidance, and passive radio frequency detection to home in on radar emissions from adversarial aircraft. A secure two-way data link using millimeter wave frequencies allows for in-flight retargeting, real-time telemetry, and mid-course updates from network sensors. This system is hardened against jamming through spread spectrum frequency hopping techniques synchronized with the J-10CS electronic warfare suite. This combination ensures that even if the launch platform disengages or is denied line of sight, the missile can continue to prosecute its target with a high probability of kill. The operational implications are transformative. India's reliance on airborne early warning and control aircraft, such as the IL-76-based A-50EI Falcon systems and the EMB-145 Netra platforms, becomes a liability, as these assets are indispensable for providing long-range radar coverage and battle management. Likewise, aerial refueling assets like the Ilyushin IL-78 tankers, which extend the endurance of frontline fighters, are placed at extreme risk. Even high-value strike assets, such as Rafale fighters armed with cruise missiles, would no longer enjoy sanctuary if operating within 400 kilometers of Pakistani airspace. By forcing India to reposition these assets more than 450 kilometers behind the front line, Pakistan effectively degrades the reach of Indian air power, opening exploitable windows for its own aircraft and unmanned platforms to penetrate contested airspace. Testing of the system during 2024 and 2025 confirmed these capabilities. 12 live fire validation launches were conducted against modified IL-78 transport aircraft simulating airborne warning targets. Results demonstrated seeker acquisition ranges of 250 kilometers, even in cluttered electromagnetic environments designed to mimic the presence of advanced jamming. The missile proved resilient against simulated S-400 radar interference, underscoring its robustness against India's most advanced surface-to-air defenses. Launch trials further validated operational flexibility, with successful engagements conducted from altitudes up to 15,000 meters and launch speeds approaching Mach 1.8. Terminal velocities achieved Mach 6, ensuring minimal reaction time for adversaries. Nevertheless, trade-offs are acknowledged. Carriage of the PL-17 reduces the J-10C internal fuel capacity by roughly a quarter, cutting endurance for combat air patrol missions to under 2 hours without refueling. The missile size also increases the fighter's radar cross-section from approximately 1.2 square meters to nearly 3.5, eroding some of the aircraft's survivability benefits against advanced radar. Unlike China's stealth-oriented J-20, which can house the missile internally, Pakistan's J-10C must carry it externally, making it more visible. These constraints are weighed against the unparalleled reach and deterrent value of the weapon, with doctrine emphasizing selective deployment against high-value targets rather than routine carriage. Even with these limitations, the integration of the PL-17 with the J-10C has introduced a tactical and strategic dilemma for adversaries that cannot be resolved through numerical superiority alone. It compels a rethinking of air strategy in South Asia, proving that the decisive factor in modern combat is not the sheer number of aircraft, but the technological sophistication and integration of their weapons and support networks. For Pakistan, this achievement represents not just a weapons acquisition, but a comprehensive rewriting of regional air combat doctrine, a declaration that it can reach beyond its borders and contest the critical enablers of enemy power projection. Through precision engineering, networked architecture, and asymmetric thinking, Pakistan has reshaped the rules of engagement and elevated its deterrence posture to a new and formidable level. Thanks, and stay connected for the upcoming videos.